Acids and bases. The earliest definition of acids and bases was suggested by chemist Arrhenius in the late 19th century. According to Arrhenius, an acid contains a hydrogen atom and dissolves in water to form hydrogen ions. For example, HCl is an acid because it has hydrogen atom, and when dissolved in water it forms hydrogen ion. Similarly, a base contains hydroxide and dissolves in water to form OH minus, which is hydroxide ion. So NaOH, it's a base. Why? Because it has OH, and when NaOH is dissolved in water, it forms Na plus and OH minus. So OH minus is produced. Later on, uh, Arrhenius' definition uh, was contradicted because we can see uh, here this H plus does not really exist in water, because what happens when this H plus is released in the water, it immediately combines with water to form hydronium ions. So the Arrhenius definition really does not work well on explaining all the acids and bases. A more general definition of acids and bases was proposed by Bronsted and Lowry. In the Bronsted-Lowry definition for acids and bases, you should able to write conjugate acid or conjugate base also. But let's go over the definitions first. Bronsted-Lowry acid is a proton donor, must contain one or more hydrogen atoms. So for example, HCl has proton. HCl is what? H plus and Cl minus. So it has H plus, means it can donate H plus. So it's a Bronsted-Lowry acid. Bronsted-Lowry base is a proton acceptor. So if it's accepting the proton, that means it must have a lone pair of electrons or extra electrons to accept the base. For example, water can act as a base because oxygen has lone pair of electrons, and those lone pair of electrons can be used to attract water, or to attract, H plus. So let's look at a few examples, and that will help. So let's look at this reaction. HCl, when dissolved in water, forms H3O plus and Cl minus. Now, what we have to do is we have to find out that on the reactant side, which one is an acid and which one is a base. And how can you find out that? By looking at the products. So let's look at HCl. HCl on the left side is HCl, but on the right side, what do we have? Cl minus. So that means HCl must be donating H plus, and then getting converted to Cl minus. So if HCl is donating the proton, that means it is a proton donor. So that means this is an acid. Acid, after losing the proton, here HCl losing the proton is forming Cl minus, and this is known as conjugate base. So first thing, acid-base reaction, proton is transferred from acid to base. Acid loses a proton to form its conjugate base. If HCl is an acid, that means H2O will be base, but let's see. If you look on the reactant side, we have H2O, but on the product side, we have H3O plus. That means water must be accepting the proton. So you must be adding H plus into that to form H3O plus. So if it accepts the proton, that means it is a base. And base, after accepting the proton, forms the conjugate acid. So let's take one more example. Here, let me get rid of all this. So, for example, here NH3, which is ammonia, reacts with water to form NH4 plus and OH minus. So we have to find out that here on the reactant side, which one is an acid and which one is a base. So look here, NH3 on the reactant side, NH3, but on the product side, it is NH4 plus. So what's happening here? Are we adding or subtracting H plus? We must be adding H plus into that, and that's why it's getting converted to NH4 plus. If H plus is getting added, means NH3 is accepting the proton. If it is accepting the proton, then it is a base. And base, after accepting the proton, forms conjugate acid. Now if NH3 is a base, that means H2O is an acid, and acid loses the proton and is forming conjugate base. So in the given reaction, name the two acids, H2O and NH4 plus. Name the two bases, NH3 and OH minus. We can also classify acids as monoprotic, diprotic, and triprotic acids. Monoprotic acids just contains one acidic proton. For example, HCl, HF, HBr. It has just one proton here. Diprotic is going to have two acidic protons. For example, H2SO4, H2SO3. These are diprotic acids. Triprotic acids, which has three protons. For example, H3PO3 or phosphorus acid or phosphoric acid.
Made with Doodlecast Pro.